Alright, welcome to lesson number 1 on factorization. The first law of factorization, common factor, right? But before we go through it, let's look at the breakdown of what we have to learn. Alright, so under factorization, number 1, we test can you take out a common factor. We're going to have difference of two squares that we're going to factorize. And factorize by taking out a common factor more than once. Factorizing trinomials where all the terms are positive. Factorizing trinomials where the last two terms are negative. Or factorizing trinomials where the middle term negative and the last term positive. You also must be able to factorize by grouping first two terms and last two terms. Factorizing sum and difference of cubes. Simplifying algebraic fractions using factorization. And grouping by arranging terms to remove common terms first, right? So that's a breakdown of what we're going to do, and do a lesson on each of these. Alright, so in short now, just to give you a definition of what we mean with factors, right? When we multiply a number of quantities together to form an algebraic expression, each of these quantities are considered to be factors of the expression. So to give you an example, if I say 6 times p times q, it can be written as 6pq. Therefore, 6 is a factor of that, p is a factor of that, and q is a factor of that. Say 8 times x to give me 8x, 8 times y, 8y. I should know that 8 is a factor of that, x plus y are all factors of that. Right? So when we factorize expression, our final answer must be expressed as a product of the numbers. Meaning product, you see there? Take out the common factor and the variables which cannot be factorized further. Right, so without further ado, first problem. Right, so the first rule of factorization, we always check for the highest common factor. So in problem number 1, I have 7p plus 14q. We assume you know 7 can divide in itself and 7 can divide in 14, therefore it is a factor. P and q, two different variables, so therefore not common factor. So if I take out 7 as a common factor, right, this is the procedure that we never show you. I say 7p divided by 7 plus 14q divided by 7. So 7p divided by 7 become p, 14q divided by 7 become 2q. Right, if you look at problem number 2, just another basic one. I have 4x minus 16y. X and y is not the same variable, therefore no common factor for the variables. But they have 4 and 16, 4 divides in itself, and 4 can divide in 16. So there, if I take out 4 as a common factor, I say 4x divided by 4 minus 16y divided by 4. So 4x divided by 4 gives me x, 16y divided by 4 gives me 4y, and the negative sign simply stays. So that's the basics of taking out the common factor, but you know as we go further now, the problems will become more complex. Right, so I hope you understand and follow. Right, so if we look at problem number 3, now we've given you more than one variable to work with. Question and exam would just say factorize. Right, so I have 3, 9, and 27. 3 can divide in itself, it can divide in 9 and 27. So there's a common factor of 3. I have x, no x. So I can't take out x as a common factor because it doesn't appear in all 3. I have y squared, and y squared. It's a common factor for all 3, so I can take that out. Then I have z, and z. Alright, so my common factor then is 3y squared z. And now I'm going to divide everything by the common factor. So that divided by 3y squared z, 3 divided by 3, 1. X squared stays x squared, and y squared cancels, z and z cancels. Minus 9xy squared over z divided by the common factor. 9 divided by 3 gives me 3. X stays x, y squared and y squared cancel, and z cancel. Alright. The negative stays. 27 divided by 3, 9. Y squared and y squared cancel, z and z cancel, so I'm left with 9. So they have successfully taken out the common factor, right? So hope you follow. Right, if we go to the fourth problem here, Can also give you where we've already created a common factor. So you should see there in blue 2a plus 5, 2a plus 5. They are common, separated by a minus sign. So if I take out this as a common factor, 2a plus 5, what's left? 4p minus the 3q. Right, so that's just a different way of doing common factor. So I hope you understand so far. I'm just showing you this process here. The second step there, you don't need to show. But I'm just showing you how I get to the answer, because most of the time you'll complain, how do we go from this to this without showing you that? Right, sometimes, you know, trying to finish the syllabus, we work faster than what we're supposed to. Alright, now in problem number 5, give you fractions. We know you'll get scared of fractions, but it's not as difficult as we make it out to be. So I have 1 over 3 and 1 over 9. In short, the top is 1, but if you look at the bottom, 3 can go into 3 and 3 can divide into 9. So you should know 1 over 3 times 1 over 3 is 1 over 9. I have x cubed and I have x4, so I can take out x cubed as a common factor. We always take the one with the lowest exponential value. I have y4 and y3, lowest exponential value for y cubed, so I'm going to take out x cubed and y cubed as common factors. So my common factor here, 1 over 3 x cubed y cubed. That whole part there, x cubed y cubed divided by x cubed y cubed. So x cubed, so remember 1 over 3 divided by 1 over 3 is simply 1. X cubed and x cubed cancel. 4 minus 3, no second law of exponents, gives me y to the power 1, that invisible 1. Right, negative 1 over 9 divided by 1 over 3 would give me 1 over 3. I have x4 y cubed, x cubed y cubed from their common factor. x4 divided by x3, 4 minus 3 gives me 1. So x to the power 1, y cubed and y cubed cancels. So they have taken out the common factor. If you have any questions or anything's not clear to you, feel free to ask in the comment section. I will try to do it better, or clearly state to me what you don't understand. I truly want you to understand and work through this and become better at doing maths. Alright, wish you nothing but the best.